Hey there, grade nines. So this is lesson 4 from chapter 1, and we are talking about surface area of other composite items. So composite items is where you kind of have things together. So you might have like a triangular prism with a rectangular prism put together to make some type of a wedge with like a landing. And you're going to try to find the surface area of those things. So what we actually have to do is try to calculate different parts of the whole. All right, so just as a reminder, so I've got some pictures up here to help you as a little bit of a refresher. I'll come to this side. So when we look at a rectangular prism, for example, we have kind of three sides that we have identical. So we've got two fronts, we've got two tops, and then we've got two sides. So like I said, we have three sides that are, what they would say, they have congruent faces. When we look at a right triangular prism, we technically have 5 faces. 2 of them will be the same. So we have, over on this side now, so we have the base of each of them. That would be the same, but then the sides could be different. Okay, if you don't have a equilateral triangle, then each of the sides could have a different area themselves. So here's an example. Okay, so they want us to maybe determine the surface area. I'm in the way again. Determine the surface area of this shape. So what do we have here? We've got, technically speaking, a rectangular prism on the bottom, and then we have a triangular prism on top. We don't really have a formula to calculate what the area is of this odd shape, right? We know we have right angles, but what we can do, and that's what they do in the example, is they actually cut it down. So what they've got going on here is they actually cut across so that we have our height of 4 centimeters. And if our initial height, which it said it was 10, now we have the height of our triangle. All right, so that's going to help us to determine everything. So when we're actually doing the solution, let's see what they're doing. So they're talking about this part right here. So we're talking about the triangular prism first. Okay, the top is overlap. What they mean by that is it's the part that we can't see, right? It's the bottom part. So how many sides do we have to focus on? We have to focus on the front, the back, the side, and the bottom. And I believe that they're doing all of those in their operation. So they're going 2, because there's 2 sides, times 8, which is the top, okay, times 3, which is the side. So they're actually doing the front face. No, sorry, they're doing the bottom. They're doing the bottom, right? Then they're doing 2, because there's 2 sides, times 8 times 4. So 8 by 4. So now they're doing the front and the back face. Okay. The last one, they're going to do 2 times 3 times 4. So they're going the sides. So then they add it all together, and they get this. You have to use proper order of operation, so you're going to multiply before you do any adding. Okay? Just wait, we're going to figure out the overlap issue in a second. All right? So now we're actually going to do the triangular prism. So in this one, we've got our 2 sides, our front and our back. And then we have this back side, and then we have the slope. Those are all pieces that we need to try to calculate. So the area for a triangle is base times height divided by 2. So they're going to go 8 times 6 divided by 2, which is what they do. And they did it by times 2 because there's 2 sides to it. Then they're going 3 times 6, so 6 times 3, which is the back face. And then they're going 3 times 8, so they're still calculating the overlap, but we'll come back to that in a second. And then they're going 3 times 10, which is our slope, okay, our thing. And then we have to follow order of operations again, so then we're ending up getting 120. So we have 136 plus 120. Okay. But then what they actually do is they erase, they subtract the overlap. All right. So when we get down to here, we're actually seeing that they subtracted the 48 because the 48 was the same. Or sorry, the 48 was what we had with our area up top here. Okay? But Why did it work? Because it was actually 24 per overlap, because that was this piece here. Where'd it go? Right here. This one is 3 times 8, and then above they did 3 times 8. So they had to eliminate 48. Or you can just not calculate it. That's your other possible option. Okay. When we're talking about a cylinder, okay, I remember this is one that a lot of people didn't like. So when we're calculating the surface area of a cylinder, we have to calculate the top and the bottom, and then we need to find the circumference to figure out what it would look like. Because remember, when we bring it into a net, it looks like a big rectangle with a square on top and a square underneath. So if we were to cut this down and open it up, kind of like a soup can or something like that. So to calculate the circumference, we can go diameter times pi, or 2 times radius times pi, which is what they're using. So their formula, they're saying 2 times pi r squared, which is going to give us the surface area for the top and the bottom, okay, the area of the circle, plus 2 times pi r times height. So we're basically calculating the circumference and multiplying it by the height, or basically kind of base times height if we turn it out. And then they're actually able to calculate it that way. So here's one more example, and then I'm just going to use the rest of them. So we have a multi-tiered cake. All right, so if you become a baker, you need to figure out how much icing you want to put on one of your wedding cakes, and you've got multiple tiers, and each tier is a little bit different. Okay, then we can actually calculate. So we have our diameter of 26, and this dotted line is just the outside of the circle. All right, that's just the outside of the circle. So we have 5 centimeters here, 5 centimeters here, and here our diameter is 14 centimeters. So we can actually go and calculate the surface area of this and one of the tops, and then you'll be able to calculate that and know if this is 14 centimeters. Okay, we could calculate the area of this whole top, okay, the whole top, and then we would subtract the area of the top part, right? So when we're talking about the bottom tier, the second tier, we'd have to subtract the area of the circle that would be on top of the cake to figure out what this little spacing on top would be. So you'd be able to calculate the entire surface area by just kind of doing some simple problem solving, and then to go all the way around each of the pieces of cake, or each of the cakes, and then cover the tops of each of them as well. All right. So with that being said, I'm going to be posting some questions for you for practice. I think the easiest thing for me to do is to give you some questions from the textbook, which you don't have, so I'll just post them into Google Classroom. You can answer your questions in a doc. Bring your questions to the Zoom, and then we'll just work on them together. And if you have any individual questions, let me know. Contact me through Hangouts. Yeah, good luck.